All right, we're going to look at our second example of quotient identities. This example says to simplify cotangent of theta divided by sine of theta cosine of theta. You can see this one's a little bit more advanced than first example we did, but that's okay because we're going to follow the same steps. Step one is to turn everything into sine and cosine. Again, I teach it this way because it always works. So first of all, we need to note that cotangent of theta in terms of sine and cosine is cosine over sine. We learned that when we learned the quotient identities. I showed the proof for that. Now the bottom is sine and cosine. That can't change, right? It's already sine and cosine, so you don't have to do anything about that. In fact, I will even check that off. So the only thing that you did was you converted cotangent to cosine over sine. Again, step one always works because once you get everything in terms of sine and cosine, you can simplify it much easier than if you have multiple trig functions like we did up here. Step two is to simplify. The way that you simplify is going to be different for every example, but typically it's just canceling stuff from the top and bottom of a fraction. Now the first thing we're going to do is realize that cosine over sine is basically the top of our fraction, okay? And then sine of theta over cosine of theta is the bottom. And I'll even show the simplification step on this slide so you don't get confused. What we can do is we can rewrite this. Let me go down one more. As cosine of theta divided by sine of theta multiplied by 1 over sine of theta cosine of theta. Because if we are dividing by this, we can just multiply the top by 1 over that, okay? That's exactly the same thing. So the rule for that is if you're dividing by something, it's the same thing as multiplying by its reciprocal. In this case, 1 over sine of theta cosine of theta. So that's all we're doing for the first step. Now we can see what? There's a cosine of theta up here. There's a cosine of theta down there. We can cancel those. So we're going to go ahead and cancel those. And now we're just left with 2 sines of theta on the bottom. And you can see that here, once we cancel these cosines, we're just going to have 2 sines on the bottom. So now we have 1 over sine of theta times sine of theta. Well, what is sine of theta times sine of theta? That's just sine squared. So the next step is to just change that sine of theta times sine of theta equal to sine squared. And the final step, remember that 1 over sine is just equal to cosecant. So 1 over sine squared is just equal to cosecant of squared. And when I taught this lesson before, I recall that some students were a little confused by that. Another way to show this, I showed over here. We could just break this apart again into 1 over sine times 1 over sine and just basically keep it like that up here. Just put a 1 right here. Okay, 1 over sine is just equal to cosecant, and that's going to be true for both of these. Cosecant times cosecant is cosecant squared, which ends up giving you the same exact answer. Either way, you will end up proving that cotangent of theta over sine of theta cosine theta is equal to cosecant squared of theta. And that's a lot simpler than what you started out with. I think everybody can agree that our answer cosecant squared theta is much simpler than cotangent over sine cosine. And again, that's the point of this lesson, is to just simplify what you're given into something simpler, right? So if you follow those 2 steps, convert everything into sine and cosine, and simplify, you'll get the right answer every time. If you have any other questions about this example, let me know.